So if you're running a high output alternator and your wiring looks like this, you might be one pull away from melting something pretty important.
So today we're going to fix that on the Nova. Welcome back, guys, to J2 Garage Works.
Faith, family, and not burning your Nova to the ground. So on the Nova, we upgraded to this 160 amp alternator, but the wiring might not be up to the task.
So factory wiring or undersized wiring is great until it's not. Heat starts to build up, you start to have voltage drop, and then worst case is it starts to turn into a toaster under there. And then you need the fire extinguisher.
Here's what we're doing. Proper wiring,
A proper fuse, and then proper connections.
wire loom and heat shrink to make it all look pretty. So what we have here, what we're going to use to wire this alternator up, is a 1/0 gauge wire. Now I stripped some back here so you can see it's got a copper look to it, but this is actually aluminum. So it's what's called copper clad aluminum. Now ideally in this situation, if we were using a solid copper strand wire, we could have went with a slightly smaller gauge. However, it is about double the cost, and its copper wire is actually pretty heavy. So the aluminum is pretty lightweight, but the downside to that is its capability to carry the same amount of amperage as a smaller solid strand copper wire is limited. So you have to generally step up a couple of sizes in a copper clad aluminum to get the same current carrying capabilities as you would in a smaller copper stranded wire. All right guys, quick electrical lesson without making everybody fall asleep. This will be short. So while we're wiring this Nova, I wanted to explain why we chose the wire size we did, because there's actually some math behind it. This is Ohm's law, and honestly it's the foundation of every electrical system on your car. Now the easiest way to think about electricity is kind of like water flowing through a hose. Voltage, or volts, is the push. It's the electrical pressure trying to move power through the circuit. Current, or amps, is the flow. That's the amount of electricity actually moving through the wire. And resistance is the restriction. Basically, that's the thing that's slowing everything down. So if resistance goes up, flow goes down. Now this matters big time in the Nova because we're running a 160 amp alternator with the battery mounted all the way in the trunk. So the charge wire has to be about 15 foot in one direction. And some people might wonder why we didn't just go from the alternator to the starter post like in a factory setup. Well, the reason is on this car, with a rear mounted battery, we also have an external kill switch mounted to it. And to stay NHRA legal, when that kill switch is turned off, the engine has to completely shut down. If the alternator charge wire is connected to the wrong side of the switch, the alternator can actually keep feeding power into the car and the engine will continue to run even with the switch off. So to prevent that, the alternator charge cable has to be routed to the battery side of the kill switch. That way, when the switch is turned off, the alternator is isolated too, and the whole electrical system shuts down like it's supposed to. The downside to that is the longer the wire gets, the more resistance it has. Now, once you start combining long wire runs with high amperage, voltage drop becomes a real thing. This is the main equation right here. V equals I times R, or voltage equals current times resistance. So even a small amount of resistance can create problems when you're pushing big amperage through a cable. That means more resistance equals more voltage drop. More voltage drop means less charging power actually making it back to the battery and more heat in the wire. That's why size matters. Smaller wire has more resistance. Bigger wire, less resistance. So for this setup, we stepped up to a 1.0 cable, especially because this is a copper-clad aluminum wire instead of pure copper. Going bigger gives us a little extra safety margin. Less resistance, less heat, less voltage drop. And we also added a 200 amp fuse near the battery. That way, if this charge wire ever shorts out, the fuse will blow before that thing turns into a giant toaster element under the car. So the short version is big alternator, a long wire run, and high amperage means you need a big wire and proper circuit protection if you want the charging system to actually work correctly. Hopefully now, Ohm's law makes a little bit more sense. So the first order of business is I gotta put a crimped end onto this wire because we gotta run this thing down across and underneath the chassis. So I'm going to start at one end because I know that's got to go to the alternator, and we'll figure out where we got to go from there. All right, so now that we got one end connected, Jenna's putting some braided nylon wire loom over that. Now this stuff is not the split loom style.
I ordered wrong.
You didn't order wrong. It actually has its purpose.
Well, no, I wanted the split, and I accidentally ordered this, and then I kept this because it wasn't bad to have on hand.
Yeah, not for stuff like this. That's a really long run. It's a little bit cheaper than the split loom stuff, but it works just as well. So she's got her work cut out for her there. So while she's doing that, I'm just going to stand here and look pretty because I ain't got nothing to do until she gets that done.
Yeah, 'cause the alternator's already on there.
The alternator we're running is from PowerMaster, part number 57294. It says it's rated at 150 amps, but our peak output amperage, I think at like 6,000 RPMs, was 161 amps. There's the new alternator down there. It is a one-wire GM unit, so I already have it mounted up. We were hunting belt sizes there because it's kind of a custom setup. Alternator's on there. After Jenna gets this thing loomed up here, we're gonna mount the one end to the alternator and then start making our run towards the back of the car. Jenna's got the wire all loomed up. We already have the existing nitrous line. It's already mounted and all that stuff. So we should be able to just zip tie right to that and make our run to the trunk. Ready?
Let's do it.
All right, so we started up here at the alternator, as you can see. Put a little bit of heat wrap around that just because, I mean, we got some distance there from the header, but better be safe than sorry. So this is the thermal barrier that we've been using. You buy it in a roll, it's cut the length, it's got Velcro on it, and you just wrap it around whatever you want to protect. So we come back here, tie there on the frame, there's a tie there down on the fender, and then it runs back down and follows the nitrous line. Comes down here. Jenna forgot some zip ties.
Hey. Oh, I did. Oops.
Yeah, zip tied all the way back here. Runs along there. Come up over the axle, up into the trunk. Don't forget your rubbers. This is a 200 amp fuse from a company called DS18. You find them on Amazon. Here's the part number. We'll put a link down in the description. But this is an A&L style fuse. So it's a wide blade fuse. It's 200 amp. A lot of guys use this in aftermarket stereo systems and stuff like that. But we're going to use it to protect the alternator wire on this vehicle. It's got nice stainless steel mounting points in here. Pretty solid. It's got a plastic base on it, but I think as long as it's, you know, in the car somewhere, not exposed to anything heat related, stuff like that, it should be pretty good. It's got a lot of good reviews on it. Plus it's got this fancy little cover on there, so kind of looks pretty clean put together. A little bulky. Placement is a little tricky, but you know, you'll figure it out. Sometimes function over fit is more important. So we're going to put a battery cable end on here, and there's a couple of different ways to do this. We use these here, nice cable lug crimpers. They got a couple of different ones. Some you can like sit in a vise and then smack it with a hammer. Works. You can solder them on. That works too. I have not had good luck trying to solder the copper clad aluminum. And I think it's because the aluminum soaks up so much heat. It doesn't I haven't gotten it to work. So we're going to use the battery crimpers. You got adjustable jaws here depending on the size cable you're running. But make sure your battery cable is on and seated. That sucker on there. Just give it a crimp. There you go. Nice tight crimp. Don't forget your heat shrink.
It's back there.
It's back there. So got our heat shrink. Luckily I can still slide it over. Sometimes you can't. If you want to know a little trick to keeping your wire loom in place, just use your heat shrink, put it over your wire loom, and now you can shrink all that stuff together. Keep your wire loom in place.
You should tell them how you use the heat gun on there to make sure that this doesn't melt, because I'm a culprit of always melting this.
Basically, you don't want to blast your heat this way because it'll for sure melt that braided nylon wire loom. So I kind of start at the top and work myself back towards it. Sometimes you'll melt a little bit, but generally it's not hateful. Sometimes your heat shrink doesn't melt straight either, and I don't know why, but it bugs the heck out of me. But at any rate, it's a good, solid, weather-tight connection. Should work pretty good. So now all we gotta do is get this from the battery side of the kill switch down to the fuse. All right, so back here in the trunk, we've got our 200 amp fuse right here, and our alternator wire comes down, goes into the fuse, comes out of the fuse, hooks to the battery post side of the kill switch, and that's over here to the battery. So hopefully that all works, and when we fire the car up, we've got good voltage coming out of the alternator, and that voltage should be matching back here at the battery. And also when we hit the kill switch, that should shut everything down.